Next talk is from a group of researchers from University of Manchester. We have Abdullah Khird, Hao Zhang, and Riza and Victor, and I believe Riza is going to present the talk. The presentation is on a pipeline for generating fact-checking explanations. Please, Riza, go ahead. Thank you.
Thank you. You can see my screen, I suppose, and you can hear me okay?
We can hear you and we can see the screen.
Okay, thanks very much. So hi everyone. As Abdullah said, my name is Riza. I'm a senior lecturer at the Department of Computer Science in the University of Manchester. And it's my pleasure today to present to you this work on kind of developing a pipeline for generating fact-checking explanations. Just to note, this is part of a bigger project called SMITE, which stands for Preventing the Spread of Misinformation with AI-generated text explanations. And this SMITE project is funded by an EU-funded program called AI for Media. So today, I think in this workshop, we also have Abdullah Khird participating, and then the other colleagues are unfortunately unable to join. So I guess I'll start with the very obvious statement, which is that, clearly fake news and misinformation and disinformation are bad. So, and when we say fake news, this could range from kind of claims which are quite difficult to verify or to fact check to ones which are kind of obvious. So for example, perhaps the one on the left here about the German government data suggesting that fully vaccinated people will develop AIDS is kind of obviously fake news, but there could also be claims which are kind of less obvious as misleading or fake news. But in any case, we probably will agree that this could lead to really dire and serious consequences. So for example, in the context of COVID, it is kind of known that a lot of people actually died because of COVID-19 misinformation. Now, there are some organizations or some kind of teams who actually put a lot of effort into fact-checking some of these claims which circulate online. An example of which is the UK-based Full Fact. So for example, the claim that you see on the right about the Falklands War is something which has been already fact-checked on the Full Fact website. Now, the problem, though, is that because of the amount of claims circulating online, it's very difficult to or kind of, impractical to continue to fact check these claims manually. So that's why there's a strong motivation for trying to automatically fact check these claims. However, our approach is a bit different. Instead of just kind of fact checking and saying whether a claim is true or false or misleading, for example, we also additionally, we want to generate an explanation as to why that claim is, for example, true or false. So here I present an overview of the pipeline that we have developed. So essentially, as input, we have a claim. So here the example claim is arson is the reason for Australian bushfires. So our pipeline begins by triggering an information retrieval model, which basically looks for documents which are relevant to the given claim. And after getting these relevant documents, those relevant documents serve as the evidence for that claim. Well, when I say evidence, it can be either supporting or refuting that claim, right? And then we take that evidence together with the claim as input to a text generation model. And this text generation model is basically where the kind of the AI and the NLP models come in, and I will talk about that a bit in the next few slides. And the output will be a paragraph, or basically some text automatically generated, which contains a human readable explanation. In this project, the main key novelty really is not so much in the generation itself, I would say, but rather that we also want to learn how to automatically evaluate the generated text. So of course, there are metrics which are kind of standard for evaluating generated text, like Rouge, for example. But in this project, we also want to make use of kind of, metrics which are more relevant to how humans perceive this kind of generated explanations. So here, our kind of aim is, rather than censorship, rather than kind of, taking away and moderating the fake news, we actually want to aim for education. In other words, educating the people by kind of, allowing them to read these explanations for fact checking. So to summarize our approach in terms of a couple of bullet points. So first, we have we collected some data. So here, our corpus consists of articles which are actually written by experts, fact-checking experts. So these articles can be retrieved using Google's fact-check API, as well as Google's search engine results API. After data collection, we have the development or the training of the fact verification model. So here we made use of T5 model, which is basically a large, or rather a state-of-the-art model, which is capable of generating text given like an input text, which also contains a prefix. And this is the one responsible for generating the textual explanation. And then the last part is the creation or the development of evaluation metrics. And here we make use of crowdsourcing to learn how people perceive the generated text. The last part I put in brackets because this is still ongoing work and we don't have any results for this yet. So to summarize, essentially what we're doing is that if you have the claim for this, we make use of the Google APIs to get something like this, which are the snippets which are relevant to the claim. And then the model then learns to summarize these snippets to generate a text explanation, which is shorter, something similar to what you see on the right here. To speak in kind of, more specific details. So if we're talking about T5, which stands for the text-to-text transformer model, it takes as an input like a full document. In this case, the full document corresponds to the entire fact-checking article, for example, from the from the fact-checked API of Google. We give that input to the T5 model, and as I said earlier, T5 learns if you provide a prefix to it. So here the prefix that we use is summarization. So this prefix is something that T5 already knows. It's already been it out of the box. It already knows how to summarize. So essentially, we're building upon this summarization task. And then the target output for the model is a much shorter article or paragraph, which serves as an executive summary of the full article, like what you see in this example. Just to give you an idea, there was a question earlier about how do we know if the generated text is good enough? So some of the standard metrics for evaluating the quality of generated natural language text would be things like Rouge, and Rouge comes in different flavors. So there's Rouge, which is based on the longest common subsequence. There's Rouge, which is based on unigrams and bigrams. So this is just to give you an idea of kind of what sort of quality are we getting from this natural language generation model. So if we use as training data just the articles coming from the full fact organizations fact-checked articles, which is like the lighter green here. So we get something kind of between 20 and 30, maybe closer to 30 in terms of the Rouge score. If we use only snippets from Google search, we get something much lower. And if we combine the fact-checked articles from full fact with results rather from Google search, then we get a better result, which is something over 30. And this is just based on different flavors of the Rouge metric. Now, if we make use of a model called LED, which stands for long former encoder decoder. So this is a version of T5 which is able to handle longer documents. Then the results are even better. So if we compare what we were getting with T5 using all of the data, both the full fact check articles and the Google search results, then we get this. And compared to using LED, which is, as I said, able to handle longer documents, then we get something which is closer to 40 or around 40. So that's just to give a sense of the quality. Now, for our next steps, we want to work on the evaluation of the generated text from the taking into account the perspective of humans. So here, what we are currently doing is crowdsourcing labels for the different kind of quality metrics of this explanation. So how we're doing that is that we present to the crowd the generated text, and then we ask the crowd what do they think of this explanation in terms of how convincing it is. Does it back up the claim? Does it summarize the evidence well? So obviously that's doing it manually, and we want to develop a model which can automatically do that. And for that, we intend to use something like, again, BERT or one of these state-of-the-art language models for the regression or classification task to automatically learn this. So just to take a couple of minutes just to show you a demo. So I probably won't run this live, but this is essentially a prototype or just a demonstrator where if you put the claim like this, 5G masks increase the transmission of COVID. And if we use the model that has been trained on our stored corpus, so what we're getting is an explanation like this. So basically you get rather the verdict, which is false, together with a short explanation. And this explanation serves as a summary of all the evidence related to COVID-19, for example, from the corpus. And then, because there was a lot of discussion about ChatGPT earlier, I took the liberty of also trying what happens if I give the same claim to ChatGPT. So, for example, here I prompted ChatGPT by saying, can you fact check the following statement? And I put exactly the same statement here. And then ChatGPT obviously gives a much longer explanation, which is also kind of, impressive and correct. So I guess the takeaway that I would like to say here is that, obviously ChatGPT has offered kind of, a lot of kind of impressive results. But I guess what our pipeline is different is that you can actually develop your own model using the pipeline that I just presented. One can easily train a T5 model or an LED model, which is probably very difficult to say the same for kind of creating your own ChatGPT model. So with that, I'd like to thank you for your attention and happy to answer any questions you might have. Thank you.
Thank you so much, Riza, for an interesting talk, really. I believe, do we have any questions? I think we have a question from Saud. Saud, if you can.
Yes.
Yeah. Go ahead, Saud.
Hello, everyone. Can you hear me?
Yes.
Yes. I'm very impressed of the pipeline that you just presented. It's very interesting, actually. So I'm a PhD student supervised by Professor Ray and Dr. Hamid Al-Salka, and my PhD actually about fact-checking websites, and we're using similar approach. I was interested about when you use these snippets in your pipeline, did it really help? Did it improve the model compared when you are working on the source of particular news? This is my first question. The second one, I mean, I'm just curious about evaluating the model. Evaluating the model. I mean, for future the automatically fact-checked explanations, is it actually extracted from the evidence that you provided from the original claims? And I mean, how do you evaluate such?
Yeah, okay, that's a good question. So I will reshare my screen briefly again to answer the question about how the snippets help or if they actually help. So on their own, as you can see in this slide, let me see if this is, yeah, can you still see the slide? Yeah. So on their own, if we use only snippets, which is the light red bar here, no, it's not very good. Yeah, so it's lower. So that's the thing with this Rouge metrics, right? I don't think you can take you can interpret the numerical value as it is, so for example, what does it mean to get 20 or 30 Rouge score? I think that's really difficult to interpret, but at least if you are comparing Rouge scores between different models like what I'm doing here, then it gives you a sense of which is a better approach or not. You see what I mean? So here, if you just look at the light red bars, which correspond to the results of using for training only the snippets from Google, then the result is the Rouge score is definitely kind of, lower than if you use the full fact-checking articles from Full Fact, for example. However, if you combine the two, if you combine the light green and the light red, or the data corresponding to the light green and the light red, then you get a better Rouge score, which is the dark green here. And then the other question you have, yeah, so I guess this is related to that. So you can obviously to evaluate the generated text, you can take a completely automatic approach, which is where metrics like Rouge, like what I'm showing here, come in. Or like I mentioned, something that we're currently working on still is to kind of, try to capture more the perspective of kind of, human-based evaluation. So here, instead of just saying, what is the Rouge score for a generated text, you actually ask the question, is this actually convincing? If you're a human, are you actually convinced by this explanation? Does it summarize it well? And this is the key novelty. I don't think there's a lot of people who've done the same. So that's what we're trying to do here, which is to crowdsource this kind of scores from people, and then to see whether a model can learn how to assign those scores automatically. So that next time when we generate a text, we can just use a model to give a score to the generated text and say, okay, this is convincing 3 out of 5, something like that.
I hope that answers your question, Saud. Thank you so much, Riza, for
Thank you, and thanks for the question as well.
Great, thank you.